Limits of absolute value functions now. We have talked about this one, okay, and how the absolute value of x, well, sometimes it's x, right, and sometimes it's negative x, and it's a positive x when x is greater than or equal to 0, and it's negative x when, well, this should make sense, right? It's pretty straightforward. What if we put a little twist on it, and what if we talked about a function called the absolute value of x minus 2? All right, well, if that's what we're dealing with, what that's going to equal is, well, instead of x, it's going to equal a positive x minus 2, and sometimes it's going to equal a negative x minus 2. And if you notice, when, it's x, so it's x. So it's either positive whatever's inside here, or it's negative whatever's inside here. If whatever inside here is this, well then, this is your inside value here. So you're either going to have a positive one of those or a negative one of those. Okay. Now when do you have each? Well, like this one over here, you take what's inside your absolute value and you set it equal to 0, and then you solve for x, but you already solved for x, so that's why your root's at 0. On this one, however, when you take what's inside and you set it equal to 0, you're going to figure out that x equals 2, which you may remember from your last year that's a transformation. It's being translated 2 units to the right. And so on this one, this would be coming in from x equals 0, or this is your root, so you'd be coming in from the right-hand side. And this, well, this is on the left, that's where your negative side, so that would be coming in from your left-hand side. So if you're taking a limit coming towards this root right here, this would be the limit of your function as x is approaching 0 from the left, from the right, and then this one would be the limit of your function as x is approaching 0 from the left. We have the same thing, except our root is not 0, our root is 2. So we are either going to be, the positive side is when x is greater than or equal to 2, and the left side is when x is less than 2. Now, the equal sign right here, whether it's there or not, is sort of irrelevant with a limit. We're just taking the limit. It does not, I don't care what it equals it to. I just want to know as it's approaching from the left and as it's approaching from the right, what does it equal? So, just to clarify, this would be the right side, and this would be the left side. Let's see if the limit of this function exists as it's approaching x equals 2. So for the limit to exist on our function as x is approaching 2, we must make sure that the limit of f of x as x is approaching 2 from the left is the exact same thing as the limit of our function as x is approaching 2 from the right side. Right now we don't know. I'll put a question mark. Well, what function do we use when we're on the left side? This is the left side, right? Well, we use this function. Let me get rid of this f of x because the f of x we use is on the left side. All right, we use this one. We use negative x minus 2. What about on the right side? When we're on the right side of 2, approaching 2 from the right side. Here, let me change the color. Let's do this one. Well, this is the one we use. We use the positive x minus 2. Let's evaluate. When you plug in your 2, you're going to get a negative 2 minus 2. Well, does that equal a positive 2 minus 2? In this case, 0 is the only number where 0, negative 0, they're the same thing. So yes, it does exist, and the limit equals 0. If the graph interests you, let's take a quick look here. So I do have the absolute value of x and the absolute value of x minus 2. And you can see that as you're approaching x equals 0, your limit is approaching y equals 0. And over here, as your x's are approaching x equals 2 from both sides, your y value is approaching 0. Let's do some examples. Here's one where we're approaching 3. I've given you the graph. I'm not really that concerned about it, so rather save you time, that's what it looks like. I want to show you how to solve these algebraically. I have the limit as x is approaching 3 of x squared minus 2x minus 3, all over the absolute value of x minus 3. Now, if the limit exists going to 3, we need to know what is the limit as you're approaching 3 from the left-hand side. And, well, here's the function. Remember, it's x squared minus 2x minus 3. And on the left side, we use the negative. Does that equal the limit as we're approaching 3 from the other side, the right side? And on that side, we use the positive. Let's solve. All right, now here, if you do plug in your 3 into here and here and here, and I will tell you, you're going to get some 0 over zeros. So let's factor. We've gone over some plans of attacks. In this case, I see this is a quadratic, and I have a factoring option, so let's factor it. This would be, what do we want? We want -3 and a +1. All right, and this would obviously factor the same way over here, so let me do that now. Now, here you can see that we have an x minus 3 in the denominator and an x minus 3 in the numerator. That's going to leave us with this. The limit as x is approaching 3 from the left, we have x plus 1 over -1. All right. Does that equal, well, on the other side here, the right side of 3, the x minus 3 cancels with the x minus 3, and what we have is x plus 1 over a +1. Let's plug in our value. When you plug in here, the 3 goes here, and that's going to be 3 plus 1 over -1. That's 4 over -1. That is a -4. Does that equal, what do we get here? Well, that's going to be a 4 over 1. That's a +4. That does not equal each other. Therefore, the limit does not exist. Now, I think if you look at the graph, it makes a little more sense. Right? As we're approaching from the left side, we're getting closer to -4, and from the right side, we're getting closer to +4. The limit does not exist. How about this one now? Again, I'm giving you the graph because, well, whatever, it's going to help you, but I want to show you how to solve these algebraically. When I ask for algebraic solutions, you need to show me that. Here's how we do it. Well, for the limit to exist, we're going towards -1, so the limit as x is approaching -1 from the left, don't forget, that's when you use the negative of whatever you see inside the absolute value sign. And in this case, that is going to be raised to the 3rd. Over here, that's just an x plus 1 squared. Well, does that equal the limit as x is approaching 1 from the other side, the right side? And on that side, well, that's when you're using the positive x plus 1. The denominator is the same. Be mindful, if you're not sure what to do with this negative here, well, you're cubing this value, right? It's either the negative of that or the positive of that. So that's why I kept it inside here to remind you, well, here you have a negative times a negative times a negative. When you have an odd exponent, you're going to have a negative left over. So, in essence, this right here is mathematically equivalent to this. And there's the limit. We're not done yet, so let's just clean this up. Does that equal, well, over here, this is going to be the same thing. Here, I'll show you. So this is obviously positive. So what's going to happen here is you can cancel both of those out with 2 of these, but you're going to have 1 left over, which means from the right, we're left with a positive x plus 1. And just to show you what happens over here, well, here you're going to cancel these, and you're going to cancel these, going to leave you with 1 of these, which means over here we have the limit as x is approaching -1 from the left. We have a negative of these. And on the right, we have this. The positive, if you will. Let's plug in and see what happens. -1, you're going to have a negative -1 plus 1. Does that equal a positive -1 plus 1? -0 does equal positive 0. The limit is 0. And here on the graph, you can see the visual of it. We're approaching y equals 0. And for our third and final example of this video, here let's do this one. Okay, we have a fraction, no big deal. You handle it the same way. This one, well, this one actually just here tells you that the answer is approaching infinity. When I copied this, it happened to have that on there. Oh well. As you can see, though, just to explain, well, 5 halves is 2.5. So as x is approaching 2.5 from the left, and as x is approaching 2.5 from the right, yes, both of your values are approaching positive infinity. Just so it's been said, on Delta Math, when you're going to the infinities, the limit does not exist. I would accept both answers. They both make sense. Now for the algebra. How did we get those? Let's follow the same pattern here to see if the limit of our function as x is approaching 2.5 or 5 halves. We must check it from the left side, and from the left side we have the negative part of the absolute value. And we want to see, does that equal, whoops, let me change color, the limit as we are approaching 5 halves, which is also 2.5, from the right side. And on the positive side, we use the positive. 5 minus 2x squared. At this point, you may notice that these two factors look fairly similar, but they're not. These two terms are switched. Well, there is a relationship and we can cancel something out, but let's pause on the problem and remind you of something over here. Okay, so let's work over here for a second. If I gave you x minus 3, well, the question is, does that equal 3 minus x? Because that would be the same concept, right? We would take these two terms and we would switch them. All right, well, let's see. Do they equal each other? They do, sort of. If I were to take a constant out of here, a -1, well, let's see what happens if I took a factor of -1 out. I would have to make that a negative x and a positive 3 because, well, then when you distribute, that would give you a positive x and that would give you your -3. So that equals each other. Which means, let's just switch these two things around. If I did 3 minus x, that's the same thing as negative x plus 3. So the answer is no, it doesn't equal this, but what x minus 3 does equal is this. Ta-da! So here's what we can do. Over here, you can take one of these out with one of these, but we have to remember to include a -1. That -1 right there. We now have the limit as x is approaching 5 halves from the left. We have a -1 over a negative. And yes, the negatives are going to cancel. Okay, let me just erase it because negative is positive. On the other side, we have the limit as x is approaching 5 halves from the right. Well, what happens over here? We're going to get rid of one of these, and we're going to get rid of one of these, but yes, we have that, and we have one of them left over, so let's reconvene. We have this, and we have this. Okay. When it's time to evaluate, that's when you drop the lim, and here, let me put that, we still don't know yet. I have 5 minus 2, and there's my variable. Well, the variable is going to be from the left-hand side, so I might try something like 2.4999. I'm trying to get something really close to 2.5. Don't forget, 2.5 is the number we're at here. Well, then, you know, we want to know, does that equal over here? We have 1 over -5 minus 2, and there's my variable. And the variable over here would be something like maybe, 2.50001, something very close on the right side. You try both of those numbers, look at your xy values there. You're going to notice that this is approaching positive infinity like the graph shows, as does the right side. If it's approaching infinity, the limit does not exist. To avoid any confusion, this is where we're at on the outline. This is the practice PDF we have in the Google Drive folder. So go to Google Drive folder. This is the handout right here. Here are your problems, and I've provided you with the answers right here. So you may want to jot them down before you shut the video off. Okay? Have a great day. Best of luck.